An airplane leaves Atlanta at 2 p.m. and flies north at 250 miles per hour. A second airplane leaves Atlanta 30 minutes later and flies north at 280 miles per hour. At what time will the second airplane overtake the first? Well, this is a DIRT problem, or distance equals rate times time. You see, we've got time, 30 minutes later. We've got rate, 280 miles per hour, 250 miles per hour. We've got distance here because both these planes are flying a distance, and that's how their rate and time are related. So we need to use this formula to help us organize our data. So first, let's find the distance for the first airplane. The rate of the first airplane is 250 miles per hour. So 250 times, and then all we know is what time the first airplane left. We don't know how long that airplane flew. So we've got to use T for time there. Now the distance for the second airplane, the rate is 280 miles per hour. And we do know a little bit about the time that the second airplane flew. If you'll notice, the second airplane is going faster than the first one. So if they left from the same place and they go in the same direction, they're both going north, then the second airplane is eventually going to catch up with the first and actually pass the first. And that's what we're trying to figure out, is at what time will the second airplane catch up to or overtake the first. So the second airplane won't have been flying as long as the first airplane when it catches up. It's going faster, and it left 30 minutes later. So however long this first airplane has been flying, the second one will have been flying that time minus 30 minutes, since it left 30 minutes later. Now if you think about this, you've got two planes leaving from Atlanta. They're both flying north. And the question is, when will the second one overtake the first one? Well, this is what we're trying to find out, is what time that will happen. Well, at that time, both of these airplanes will have flown the exact same distance. We don't know what that distance is, but we know that it's the same. So we can take these two distances and we can set them equal. So the distance of plane 1, 250 t, is equal to the distance of plane 2, 280 times the quantity, t minus 30. And now we need to solve for t. So the first thing we want to do is distribute our 280. So I'm going to bring down this 250t equals 280 times t, 280t, minus 280 times 30. 280 times 30, 0 placeholder, 3 times 0 is 0, 3 times 8 is 24, 3 times 2 is 6, plus 2 is 8. That's 8,400. Now we need to get all of our variables on the same side of the equation. We don't want to have t on the left side and t on the right side. So I'm going to subtract 280t from both sides. 250t minus 280t. I'm taking away more than I have, so I'm going to end up with a negative. And the difference between 280t and 250t is 30t. So negative 30t equals, by subtracting this 280t, I've actually canceled that term on the right side. And I'm left with negative 8,400. To solve for t, then, we need to divide both sides by negative 30. Negative 30 divided by negative 30 is 1, times t is simply t. Negative 8,400 divided by negative 30. First of all, a negative divided by a negative is a positive. Then we can cancel a 0. And really all we have to do is divide 840 by 3. Really, I'm running out of space here. I'm going to get rid of this so we can divide 840 by 3. 3 goes into 8 2 times. That's 6. Subtract and you get 2. Bring down the 4. 3 goes into 24. 8 times. 3 times 8 is 24. Subtract and you get 0. Bring down your 0. 3 goes into 0 0 times. So it's 280. But 280 what? Well, if you'll recall, we did t minus 30 minutes. So that would mean that these t's are in minutes. So we just found how many minutes the first plane, t, the first plane would have been flying when the second plane overtook it. So we need to first convert these minutes into hours and minutes so that we can then find the time, what time it was when that happened. So to convert these minutes into hours, there are 60 minutes in 1 hour, which means we need to divide 280 by 60. So we've got 60, 120, 180, 240. So 60 goes into 280 4 times and you get 240. You subtract and you get a remainder of 40 minutes. So that's 4 hours, 40 minutes. So 4 hours, 40 minutes after the first plane left at 2 p.m. is when the second plane overtook it or caught up with it or had traveled the same distance. So 2 plus 4 hours is 6 and 40 minutes. So at 6:40 is when p.m. is when that second plane overtook the first. Answer C. Which of the following expressions is equivalent to the quantity A plus B times the quantity A minus B? Well, this is actually a rule that you would memorize, but you don't have to memorize it. You can always just take these binomials and multiply them together using FOIL. The F stands for first, meaning to multiply the first terms in each set of parentheses. So A times A. And A times A is A squared. Then O stands for outer or outside. So you multiply the two terms on the outsides, or A and negative B. So A times negative B is negative AB. I stands for inner or inside. So you multiply the two terms on the inside, B and A. B times A is BA or AB, so plus AB. And finally, the L stands for last. So you multiply the two terms that are in the last positions of each set of parentheses. Positive B times negative B, which is negative B squared. Then to simplify, we combine like terms. Negative AB and positive AB are like terms, and they cancel each other out because they're additive inverses of each other, or opposites. So we're left with a squared minus b squared, or answer A. Jamie had $6.50 in his wallet when he left home. He spent $4.25 on drinks and $2 on a magazine. Later, his friend repaid him $2.50 that he had borrowed the previous day. How much money does Jamie have in his wallet? So the first thing I'd like to do is find the total amount of money that Jamie spent. And I see that he spent $4.25 and $2. So to find the total amount of money he spent, I need to add $4.25 plus $2. And it's very important that whenever you add numbers with decimals or subtract numbers with decimals, that you line up the decimals. So now I'm ready to add, and I can just bring my decimal down before I even start. 5 plus 0 is 5, 2 plus 0 is 2, 4 plus 2 is 6. So now I know he spent a total of $6.25. And if he spent that much money, then that's money that is taken away from what he had. So he started with $6.50, but he spent $6.25. So I have to subtract what he spent from what he had before. And again, we need to line up our decimals. I can't take 5 from 0, so I'm going to borrow from this 5. It becomes a 4. And now I have 10 minus 5 is 5. And 4 minus 2 is 2. Can bring down that decimal. 6 minus 6 is 0. So that means after he spent the $4.25 on the drinks and $2 on the magazine, he only had 25 cents left. But his friend repaid him $2.50, which means his friend gave him $2.50. So that's money that's added to his total. So now I'm going to take what he had after he spent his money and add the money his friend gave him. And again, we line up our decimals. 5 plus 0 is 5. 2 plus 5 is 7. Bring down the decimal. 0 plus 2 is 2. So after spending money and getting repaid money, he now has a total of $2.75, which is answer D. The table shows the cost of renting a bicycle for 1, 2, or 3 hours. Which of the following equations best represents the data? If C represents the cost and H represents the time of rental. Since this is a multiple choice question, you could always substitute these values or substitute these values for hours into your equation and see if you get the cost. For instance, you could replace H with 1, and you have $3.60 or $3.60 times 1, which is $3.60, which is the cost for 1 hour. And then do the same with 2 and with 3. Because sometimes an equation will work for one set of data, but not for the other 2. So you should test it on all of them. However, I'll show you how to solve this problem if it weren't multiple choice. So we're going to write our own function rule using the data. First, looking at hours and cost, your cost is dependent on the number of hours you rent the bike. Cost then is the dependent variable. And I want to focus on my dependent variable and see what kind of changes are happening. So from $3.60 to $7.20, I'm adding $3.60. From $7.20 to $10.80, I'm again adding $3.60. So I can see that the change in Y is constant, or the change in the cost in the dependent variable is constant. I want to now compare and see what's happening with my independent variable, my time. So from 1 to 2, I increase by 1. From 2 to 3, I also increase by 1. So there's a constant change in my independent, my time, as well. This tells me that there's a linear relationship here. So to write my function rule, I simply need to find my rate of change, which is the change in Y divided by the change in X. And the Y, that's the dependent variable, whereas X is the independent variable. And we've already established that our cost is dependent, therefore our cost is our Y. And we've already found the change in Y, it's $3.60. Divided by the change in X, 1. So our rate of change is simply $3.60. And that rate of change is what you're multiplying the independent variable by to get the dependent variable. So I've now found that the cost is equal to $3.60 times my independent variable of H. And then we can check and see if it works. So let's replace H with 1. $3.60 times 1 is $3.60. Try it with 2. $3.60 times 2 is $7.20. Finally, 3. $3.60 times 3 is $10.80. So that verifies that our function rule works for this situation and is correct. So answer A. Figure 9 shows 2 quarter circles centered on the origin of the Cartesian coordinate plane. The inner circle has a radius of 2 units. The outer circle has a radius of 3 units. What is the area of the shaded region? So that's right in here. And so if you can just imagine it, this circle would continue going, as would this larger circle. So since it's been split into quarters, all we're finding the area of is a quarter of those circles. So first let's start with what the formula for the area of a circle is. It's pi times radius squared. As we discussed though, this is only a quarter of these circles, so our area is a quarter of the area of these circles. So, and then we need to find the area of just the part between those 2 circles. So that would be the area of the large circle minus the area of the small circle. And the area of the large circle would be pi times the radius, which is 3 squared, minus the area of the small circle, which would be pi times 2 squared. And the 3 and the 2 came from the radius. The radius of the small circle is 2, and the radius of the outer circle has a radius of 3. So that's where these numbers came from. And now let's simplify that. So we get area is 1/4 of 3 squared is 9, so 9 pi minus 2 squared is 4, so 4 pi. Now since each one of these terms has a pi in it, we can factor the pi out. So we get area equals 1/4 pi times the quantity 9 minus 4. And then we can simplify 9 minus 4, so we have area equals 1/4 pi times 5. And 1/4 times 5 is 5/4, so that's 5/4 pi. But of course, if you're needing to bubble this in on an answer sheet, then you don't have the option of bubbling pi. So we're going to have to multiply 5/4 times pi. And 5/4 times pi is 1 and 25/100 pi. And for pi, we'll just use 3 and 1400. So we're doing 1 and 25/100 times 3 and 1400. And that I'm going to do over here. So 3 and 1400 times 1 and 2500. And that's my pi. 5 times 4 is 20. 5 times 1 is 5. That's 7. 5 times 3 is 15. Put a 0 placeholder. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Put 2 0 placeholders. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. Add that together. That's 0. 7 plus 8 is 15. Carry the 1. 5, 9, 10, 12. Carry the 1. 6, 7, 8, 9. 3. And then we have 4 numbers behind the decimal. 1, 2, 3, 4 numbers behind the decimal. So, and then we could round this to 3 and 93/100 would be the area of just the shaded region. The Charleston Recycling Company collects 50,000 tons of recyclable material every month. The chart shows the kinds of materials that are collected by the company's 5 trucks. What is the second most common material that is recycled? This is a pie chart, and a pie chart is a visual representation of data. The data represented in the chart will add up to a total of 100%. 40% plus 25% plus 15% plus 5% plus 15% is a total of 100%. The larger the slice, the larger the percent. And the larger the slice and percent means the more common that piece of data is, or the more times that data occurs. So in this case, they're asking what the second most common material is. And we can see that paper is the most commonly recycled material. It has the largest slice of the pie, and thus the largest percentage. So the second most common recycled would be glass at 25%. B. Elijah drove 45 miles to his job in an hour and 10 minutes in the morning. On the way home, however, traffic was much heavier, and the same trip took an hour and a half. What was his average speed in miles per hour for the round trip? So first, let's determine just how far Elijah went. It was 45 miles to his job, and then he had to drive 45 miles back home. So he drove that 45 miles twice, or 90 miles. Speed is calculated by dividing your distance by your time. So we've got his total distance. Now we need to find his total time. It says it took him 1 hour and 10 minutes to get to his job. So 1 hour and 10 minutes is a total of 60 minutes plus 10 minutes, 70 minutes. Then on the way home, it took him 1 hour and a half. So 1 hour, 30 minutes. Again, 1 hour, 60 minutes plus 30 minutes means a total of 90 minutes. And I'm converting the time into minutes just because it makes those units easier to work with. When you've got hours and minutes together, it's easier just to bring them all into minutes, put them all in that same unit of minutes. So 70 plus 90 is 160 minutes for his total travel time. So again, to calculate his speed, we need to divide his total distance by his total time. So 90 miles divided by 160 minutes. Well, the first thing I could do to simplify this is I could cancel a 0. So now it's just 9 divided by 16, which will be a lot easier to work with. So I have 9 divided by 16. 16 doesn't go into 9 at all. That's 0, which means I'm going to need to add a decimal and a 0. 16 goes into 90 5 times. So 16 times 5. 5 times 6 is 30. Carry the 3. 5 times 1 is 5 plus 3 is 8. So that's 80. We subtract and we get 10. So we need to add another 0 and bring it down. So 16 goes into 100 6 times. Since it went into 16 times 5 was 80, then one more time would be 96. And then we subtract and we get 4. Add another 0, bring it down. 16 goes into 40 2 times. 16 times 2 is 32. So we subtract and we get 8. Add another 0, bring it down. And 16 goes into 80 5 times. 16 times 5 is 80. We subtract and get 0. So that means that his speed in miles per minute would be 0.5625. But they didn't ask us for his speed in miles per minute. They asked us for his average speed in miles per hour. So now I have to convert this speed into miles per hour by multiplying it by 60, since there are 60 minutes in 1 hour. So if he travels this speed every minute, then we multiply by 60 to find the speed in miles per hour. So first start with your 0 placeholder. 6 times 5 is 30, so that's 0, carry the 3. 6 times 2 is 12, plus 3 is 15. 6 times, put that in the wrong place, oops. 6 times 6 is 36, plus 1 is 7, carry the 3. 6 times 5 is 30, plus 3 is 33. And we have 1, 2, 3, 4 numbers behind the decimal. So your answer should have 4 numbers behind the decimal. So it's 33 7/75 miles per hour, which is the same as 33 3/4 miles per hour, since 3/4 and 7/75 are equal. Kyle bats third in the batting order for the Badgers baseball team. The table shows the number of hits that Kyle had in each of 7 consecutive games played during 1 week in July. What is the mode of the numbers shown in the table? Mode means the number that occurs the most. So out of these numbers, 1 occurs 1, 2, 3 times. 2 occurs twice. 3 occurs once, and 4 occurs once. So the number that occurs the most, or the mode, is the number 1. The distance traveled by a moving object is computed from the relation distance equals rate times time, where r is the rate of travel, speed, and t is the time of travel. A Major League pitcher throws a fastball at a speed of 125 feet per second. The distance from the pitching rubber to home plate is 60 5/10 feet. How long, in seconds, does it take a fastball to travel this distance? Compute your answer to the nearest hundredth of a second. So first I'm going to pull out this formula. That's going to be very helpful in solving this problem. Distance equals the rate times the time. Now I want to take the information I was given and substitute it into this equation. So they told me the speed of the ball. And remember, speed is your rate, r. So that means I'm going to replace r with 125. Then they also gave me the distance, 60 5/10 feet, which means I'm going to replace d with distance, 60 5/10. And so t is what I'm trying to find. So the t will stay there in my equation. So in order to find t, to find time, we need to solve for t by dividing both sides by 125. 125 divided by 125 is 1, times t is t. So to find our answer, we need to divide 60 5/10 by 125. So I'll work it over here. 60 5/10 divided by 125. So that decimal goes right there. 125 does not go into 60, but it does go into 605. So you've got 125, 250, 500, and then one more time would be 625, so that means it only goes 4 times. And that is 500. We subtract, and we get 105. Add another 0, bring it down. We want to see how many times 125 goes into 1,050. Well, if you'll remember that 125 times 4 was 500, then it would go twice as many times as that, so 8 times. And that would give us 1,000. We subtract that and we get 50. Add another 0, bring it down. And 125 goes into 500 4 times. 125 times 4 is 500. Subtract and you get 0. So that means that the time would be 484 thousandths seconds. But if we go back to our instructions, it said to compute your answer to the nearest hundredth, which means I need to round this to the hundredths place. The 8 is in the hundredths place, and that 4 tells the 8 to stay the same. So it's simply 48 hundredths seconds. Jesse invests $7,000 in a certificate of deposit that pays interest at the rate of 7.5% annually. How much interest in dollars does Jesse gain from this investment during the first year that he holds the certificate? This is a great problem to use this formula on. And some people call it IPERT, just as a way to remember it. The I stands for the interest, the amount of interest in dollars, like what we're trying to find. P stands for principal, or the amount that's being invested initially. That would be our $7,000. The R is the rate, or the percentage, but written as a decimal. So we're going to take 7.5% and write it as a decimal. And that'll be our rate. And then T stands for time. So you may want to make a note of that. This I is the interest. P is the principal. R is the rate as a decimal. And the T is the time. So we're going to take our information from our problem and plug it in. So our amount of interest is equal to the principal, $7,000, times the rate as a decimal again. So we're taking 7.5% and changing it to a decimal, which means taking the decimal and moving it 2 places to the left. So you add that 0, so it's 75 thousandths, and then times the year, or the time, and we're just trying to find out about the first year, so that means it's been in there for 1 year, and then we just need to multiply those things together. So 1 times anything is just that, so I can really kind of ignore that. So I just need to multiply these 2 numbers together. So I have this 75 thousandths, and I'm going to put it on top because it's very easy to multiply times 7,000, since the first thing I'm going to do is just write down those 3 zeros. And then the only number I really have to multiply by is the 7. So 7 times 5 is 35. Write the 5, carry the 3. 7 times 7 is 49. Plus 3 is 52. And then we have 3 numbers behind the decimal, so 3 numbers behind the decimal. And that means that he's going to make $525 off of his investment. So that's the number you would need to bubble in, is 525. A tire on a car rotates 500 RPM, or revolutions per minute, when the car is traveling at 50 kilometers per hour. What is the circumference of the tire in meters? Well, the first thing I want to do is take this 50 kilometers per hour and convert it into meters, since that's what they want the circumference in. So to convert kilometers to meters, I multiply it by the conversion factor of 1,000 meters is 1 kilometer. And when I multiply these fractions, I can cross-cancel these units, kilometers, and I'll be left with meters per hour. And I'll go ahead and do that first. So our kilometers cross-cancel. 50 times 1,000 is 50,000 meters per 1 hour. So every hour, this car goes 50,000 meters. And we know that it goes 500 revolutions every minute. So then I want to convert my 50,000 meters per hour into meters per minute so I can more easily compare it to my revolutions per minute. So I'll multiply it by the conversion factor of 1 hour is 60 minutes. So again, my hours cross cancel since I'm multiplying fractions, and I get 50,000 meters every 60 minutes. What I want to find, though, is what 1 revolution is. How many meters is 1 revolution? Because 1 revolution is 1 time all the way around the tire. And that would be the circumference, which is what they're asking me for. So I'm going to take this 50,000 meters per 60 minutes and multiply it times my 500 revolutions per minute. So every 1 minute, the car goes 500 revolutions. So that again, my minutes, these units, minutes cross cancel. And I can cross cancel my 50,000 and my 500 by dividing them both by 500. And 500 divided by 500 is 1. And 50,000 divided by 500 is 100. So then 100 meters times 1 is 100 meters divided by 60 revolutions. So now I found that every 100 meters, this car, it's going 60 revolutions every 100 meters, which I can then simplify by canceling out the zeros, and I get 10/6 meters per revolution. So it goes 10/6 of a meter every revolution. And again, a revolution is 1 time all the way around the wheel, which is the circumference. So our circumference is 10/6. Mrs. Patterson's classroom has 16 empty chairs. All the chairs are occupied when every student is present. If 2/5 of the students are absent, how many students make up her entire class? This is a great problem to use a proportion to solve. We can take this fraction, 2/5, and use that as our first ratio. 2 being the amount of students who are absent out of the 5 total. And that equals, again, number of students who are absent divided by the total. And it says in the problem that there are 16 empty chairs, which means there are 16 students missing, since usually all the chairs are occupied when every student is present. So every empty chair is a student who's absent. So we have 16 absent students out of, and this is what we don't know. What's the total? How many students make up her entire class? And to solve a proportion, we simply need to cross multiply. 2 times x is 2x, and that equals 16 times 5, which is 80. And then we solve for x by dividing both sides by 2. And x equals 40. So that means there are 40 students in her entire class. Which of the following could be a graph of the function y equals 1 divided by x? Let's start with b. This is a linear function. In fact, it even looks like the parent function of a linear function, which is y equals x. So not y equals 1 divided by x. By the way, this is called a rational function. The root ratio means a comparison of two numbers, or a fraction, and b is not the graph of a rational function. It's the graph of a linear function. C is a quadratic function graph. This parabola is graphed from a quadratic function. And this also looks like the parent form. The parent form of a quadratic function is y equals x squared. So this would also not be the graph of a rational function. On D, this is what an exponential function looks like. It starts out increasing slowly, but then it begins increasing faster. And that parent function is y equals a number to the x value, or b to the x. That's not the parent function, that's just the form. And it's actually y equals a times b to the x. But again, not a rational function. And then, so we can eliminate D. And then on E, this is very similar to B. It's another linear function. It graphs a line. And it's not the parent function this time, but it's still a linear function. So it's in this form, y equals mx plus b. So still, with a linear function, our x is not in the denominator like our rational function. So that one's out as well. Which means we're left with A, which is the graph of a rational function. Something you can think about with rational functions is that the only number you can't divide by is 0. Notice how on this graph, your domain is never 0. On this side of our graph, it's approaching 0 and then it turns down sharply away from 0 because your x value can never be 0 since you cannot divide by 0. It's the same thing in the first quadrant. Again, it's approaching 0 and then it turns sharply away from 0 because x can never be 0. Your y value will also never be 0. So again, you can tell in this graph our y value never reaches 0. However, in all of these other graphs, we do have an x value of 0. There it is, right there. Right there, our x value of 0. And so that's another way to tell that A is the solution. A is the graph of the function y equals 1 divided by x. Raphael has a business selling computers. He buys computers from the manufacturer for $450 each and sells them for $800. Each month he must also pay fixed costs of $3,000 for rent and utilities at his store. If he sells N computers in a month, which of the following equations can be used to calculate his profit? Profit. Profit is found by subtracting the money you spend from the money you earn. So we know that he earns $800 for each computer that he sells. That's money he earns, $800 for each computer, which means to multiply times the number of computers he sells. And that's all the money he makes, so everything else is money he spends. So from the money he earns, we need to subtract $450 for each computer, because that's how much he has to pay the manufacturer. So minus 450 in. And we also have to subtract $3,000 flat. So just 3,000. Now if we compare what we have to these equations, we know we can already eliminate A. It doesn't even take the 3,000 into account, so A is out. On B, if we distributed this in, we'd be subtracting 3,000 in, which is not right. We're not losing $3,000 for every computer we sell, so B's out. On C, it has us multiplying 3,000 times in, which would be great. He'd be making tons of money, but that's not this situation. In D, when we distribute the N, the number of computers, N times 800, 800 N, minus N times 450, so minus 450 N, and then minus 3,000. So D's looking pretty good. The problem with E is, instead of subtracting the 3,000 he spends on rent and utilities, they're adding it back in like that's more money he's making. But he's not making that money, he's losing that money. So D would be the correct answer choice. Morris started work today at 7 a.m. and worked until 4:30 p.m. He earns $12 per hour for his regular shift, which is 8 hours, and 50% more per hour for overtime. How much did Morris make today? The first thing we want to do is find out how long Morris worked. So if he worked from 7 a.m. to 4:30 p.m., then from 7 a.m. to noon, that's 5 hours. And from noon to 4:30 p.m. is 4.5 hours, which means he made he worked for a total of 9.5 hours. Now they told us that he makes $12 an hour for just his regular 8-hour shift. So for 8 of these hours, he made $12 an hour. And the rest, the leftover, so 1.5 hours, would be his overtime. And for overtime, he makes 50% more per hour. So his regular pay would be 8 hours times $12 an hour, which is $96. But then for overtime, he makes 1.5 times as much as he made for his regular shift. So 12 times 50% more, which would be 1.5, times he worked that for 1.5 hours. So first I'm going to multiply 12 times 1.5. 5 times 2 is 10, carry the 1. 5 times 1 is 5, plus 1 is 6. Put a 0 placeholder. 1 times 2 is 2. 1 times 1 is 1. So we add this together and we get 180, but there's one number behind the decimal. So that means that he was making $18 an hour for that 1.5 hours that he worked overtime. So now we multiply 18 times 1.5. And 5 times 8 is 40. Carry the 4. 5 times 1 is 5, plus 4 is 9. 0 placeholder. 1 times 8 is 8. 1 times 1 is 1. We add those together. 17, carry the 1. One number behind the decimal. One number behind the decimal. So that means he made $27 in overtime. So his total amount that he made that day would be the sum of the amount of money he made for his regular shift and the amount he made for overtime. So we need to add $96 and $27. 7 plus 6 is 13. Carry the 1. 9, 10, 11, 12. So that means he made $123 that day. Which of the following statements is true? A. Perpendicular lines have opposite slopes. Close but not quite. It's missing an important word here, and that word is reciprocal. Perpendicular lines have opposite reciprocal slopes, so that is not true. B. Perpendicular lines have the same slopes. Again, not true. That would be parallel lines that have the same slope. Parallel lines are lines that never touch, never intersect. So their slopes would need to be the same so that they would never touch each other. For instance, let's say these lines had a slope of 1/2. Then this line we go up 1 over 2, up 1 over 2, same thing here, up 1 over 2, up 1 over 2, and that way our lines never touch. So it's parallel lines that have the same slopes. So this statement is also not true. C. Perpendicular lines have reciprocal slopes. Again, close but missing a very important word, and that is opposite. They have opposite reciprocal slopes. So this is also not true. D. Perpendicular lines have, finally, opposite reciprocal slopes. This statement is true. Perpendicular lines do have opposite reciprocal slopes. And E is also not true. It says they're unrelated. Oh, that is so not true. They definitely are related. For instance, let's just take the graph of y equals 2x and y equals negative 1/2 x. These are two lines that have opposite reciprocal slopes. Opposite meaning that they have different signs. One's negative, one's positive. And reciprocal meaning that the fraction is flipped. So this slope is 2 over 1, whereas this one is negative 1 over 2. Notice how the fraction is flipped. So first I'll graph y equals 2x. Let me put some marks on my graph here. So y equals 2x, we would go up 2 over 1. And y equals negative 1/2 x, down, okay, sorry, we could actually graph a line here. It's going through the origin because there is no y-intercept. So there is that line, the y equals 2x line. And then y equals negative 1/2 x, again, would also go through the origin since it has no y-intercept. And from there, we would go down 1 and over 2. So you can see how these lines intersect each other at right angles because they have opposite reciprocal slopes. Which of the following is a solution to the inequality 4x minus 12 is less than 4? First, we should solve for x in this inequality. So we're going to add 12 to both sides, bring down our 4x, minus 12 plus 12 is 0, so that cancels. Bring down our less than sign, and 4 plus 12 is 16. Then we need to divide both sides by 4. 4 divided by 4 is 1, times x is x, is less than 16 divided by 4 is 4. Keep in mind when solving inequalities that if you multiply or divide both sides by a negative number, you must flip the inequality symbol. In this case, we didn't have to, since we didn't divide both sides by a negative number. It's all about that negative. So now we can apply these answer choices. We want to find which one of these numbers is less than 4. Is 7 less than 4? No. Is 6 less than 4? No. Is 5 less than 4? No. What about 4? Is 4 less than 4? No. If this were a less than or equal to sign, if it said x is less than or equal to 4, then yes, 4 would be a solution because 4 is equal to 4. And it only has to be one, either less than or equal to. But in this case, it's not a less than or equal to sign. It's simply a less than sign, meaning that this number must be smaller than 4. So our answer is E. 3 is less than 4, or 3 is a smaller number than 4. David bought 200 shares of Oracle stock yesterday and sold it today. His profit was $22. At what price did he buy the stock yesterday? We have this table of information to use. So we're only focusing on Oracle stock, which presently is being sold for $19.11 per share. It tells us that he bought 200 shares and made a profit of $22. So the first thing we want to do is find out his profit per share, which means we need to divide his profit by his number of shares. 200 does not go into 22, so I have to add a decimal and a 0. Now 200 will divide into 220. 200 goes into 220 one time. And 200 times 1 is 200. We subtract and we get 20. So we add another 0 and bring it down. 200 goes into 200 one time. 200 times 1 is 200. We subtract and we get 0. Now we know that he made 11 cents per share. If today's price per share is $19.11, then we have to subtract his profit to find out how much he bought them for the day before. So $19.11 minus 11 cents would just be $19. Answer B. Which of the following expressions is equivalent to x cubed times x to the 5th? First of all, we need to recognize that when you have two letters or a number in a letter next to each other with no operation symbols in between them, meaning there's no addition sign, subtraction, division, it is always understood that without any of those other operation signs, that we are multiplying these together. So this is x cubed times x to the 5th. And an exponent simply tells you how many times to multiply the base times itself. So x cubed means we're multiplying x times itself 3 times. And then we're multiplying that times x to the 5th, which is x times itself 5 times. So really, we're multiplying x times itself a total of 1, 2, 3, 4, 5, 6, 7, 8 times. So x cubed times x to the 5th is the same as x to the 8th. Now there is a rule for this so that you don't have to go through this step every time. And the rule is when you multiply with the same bases, the base being, like in this case, x, then you simply add the exponents together. So 3 plus 5 is 8, so it's x to the 8th, which is answer choice D. Rachel spent $24.15 on vegetables. She bought 2 pounds of onions, 3 pounds of carrots, and 1.5 pounds of mushrooms. If the onions cost $3.69 per pound and the carrots cost $4.29 per pound, what is the price per pound of mushrooms? So first I want to figure out how much money was spent on the onions that were $3.69 per pound and how much was spent on the carrots that were $4.29 per pound. So let's start with the onions. Those onions cost $3.69 for every pound that's purchased. And she purchased 2 pounds. So we need to multiply $3.69 times 2 to find the total amount of money spent on onions. So 2 times 9 is 18, carry the 1. 2 times 6 is 12 plus 1 is 13, write the 3, carry the 1. 2 times 3 is 6 plus 1 is 7. 2 numbers behind the decimal, 2 numbers behind the decimal. So that means she spent $7.38 out of her total on onions. We're going to do something similar to find the total amount of money spent on carrots. So next we'll deal with our carrots. The carrots were $4.29 per pound. So $4.29 times 3, since she bought 3 pounds of carrots. 3 times 9 is 27, write the 7, carry the 2. 3 times 2 is 6, plus 2 is 8. And 3 times 4 is 12. 2 numbers behind the decimal, 2 numbers behind the decimal. So she spent a total of $12.87 on carrots. And so now I'm going to find the total spent on onions and carrots. So that means I'm just going to add these two values together. So $12.87 plus $7.38. Make sure that when you add or subtract decimals that you line those decimals up. So we can go ahead and bring that down right now. 7 plus 8 is 15. 8, 9, 10, 11, 12. 7, 9, 10. So that means she spent $20.25 on the onions and carrots. And that, knowing that, will help us find out what amount was left to be spent on the mushrooms. Since I know her total spent on all of the vegetables is $24.15, I can take that total and subtract $20.25, which was spent on onions and carrots, and what I'll have is the amount of money she spent on the mushrooms. So again, we line up our decimals. 5 minus 5 is 0. I can't take 2 from 1, so I borrow from the 4. It becomes a 3. Then I have 11 minus 2, which is 9. Bring that decimal down. 3 minus 0 is 3. So she had $3.90 to spend on mushrooms. But what we need to know is what the price per pound was, which we can find using this information. She bought 1.5 pounds of mushrooms. So we need to take the total amount spent on mushrooms and divide that by how many pounds of mushrooms she purchased, which was 1.5 or 1 5/10. Now we need to move the decimal one place in both of our numbers, so that's where it is now. And 15 goes into 39 2 times. 15 times 2 is 30. Subtract and you get 9. Bring down the 0. 15 goes into 90 6 times. 15 times 6 is 90. Subtract and you get 0. So no remainder, but we can add a 0 here since we're talking about money. So that means that the mushrooms were $2.60 per pound, which is answer A. In the figure, segment BC is 4 units long. Segment CD is 8 units long. And segment DE is 6 units long. What is the length of segment AC? The first thing I'd like to do is take this information and actually put it on my picture. So segment BC is 4 units long. Here's segment BC, it's 4. Segment CD is 8 units long. CD is 8. And segment DE is 6 units long. DE is 6 units long. These triangles are not congruent, and that's obvious. If you're looking at them, you can see this triangle is smaller than the other one. However, these right angles are congruent. These vertical angles are congruent. And since 2 angles of this triangle are congruent to 2 angles of the other triangle, that means that the third angles, angle E and angle A, are congruent to each other. Therefore, these 2 triangles are similar to each other because all 3 of their corresponding angles are congruent to each other. And since these triangles are similar, that means that their corresponding sides are proportional. You see that segment BC is half of segment CD. 4 is half of 8. So if we can find the length of segment CE, then we know the length of segment AC is half of that. We're going to find the length of segment CE using the Pythagorean theorem. A squared plus B squared equals C squared. We have our 2 legs. 8 squared plus 6 squared equals C squared. 8 squared is 64 plus 6 squared is 36 equals C squared. 64 plus 36 is 100 equals C squared. Then to solve for C, we need to square root both sides. The square root of 100 is 10, and the square root of C squared is C. So the length of segment CE is 10. And again, the lengths of the sides of triangle ABC are half the corresponding sides of triangle CDE. So since the length of segment CE is 10, that means that the length of segment AC is half of that, or 5. So answer B. If x plus y is greater than 0, when x is greater than y, which of the following cannot be true? This word when is very important because it means we're only looking at the situations when x is greater than y. So first we should go through our answers and eliminate the ones that don't satisfy this inequality. Is 3 greater than 0? Yes, so it stays. 6 is greater than -1. so it stays. Negative 3 is not greater than 0, which means C must be eliminated as a choice. Negative 4 is not greater than negative 3, so it must also be eliminated as a choice. 3 is greater than negative 3. So the 3 answers left are the only ones that satisfy this inequality. So now we need to check to see if they satisfy the first. So we'll take A, 3 plus 0 is greater than 0. 3 plus 0 is 3, and that is greater than 0, so it works. B, 6 plus negative 1 is greater than 0. 6 plus negative 1 is 5, and 5 is greater than 0. And finally, E, 3 plus negative 3 is greater than 0. 3 plus negative 3 is 0. But 0 is not greater than 0. 0 is simply equal to 0. So this one is not true. So we found our answer, E. Dorothy is half her sister's age. She will be 3/4 of her sister's age in 20 years. How many years old is she? We have two unknowns here. We don't know Dorothy's age, and we don't know her sister's age. So I'm going to make up two variables for this. I'm going to use D for Dorothy's current age. And I'll use S for the sister's current age. And I say current because they're talking about their ages now and then also their ages in 20 years. But what we want to know is how many years old she is now. So we're going to deal with their current ages. So first we have that Dorothy is, and is in math means equals. It's one of my favorite words. I love the equal sign. So Dorothy equals half her sister's age, so half S. So it's kind of like translating. You're translating from words into mathematical equations. The next sentence says she will be, so Dorothy, will be 3/4 of her sister's age in 20 years. So Dorothy in 20 years will be 3/4 of her sister's age in 20 years. Remember that D and S were Dorothy and her sister's current ages. So when they talk about in 20 years, that means we have to add 20 to their current age. So Dorothy's age in 20 years, so plus 20, will be, or equals, 3/4 of her sister's age, also in 20 years. So we want to solve for Dorothy's age, obviously, and we can do this in lots of different ways. But the first thing I notice is that since I know that D is 1/2 S, I can replace D in this equation with 1/2 S, and that's called substitution. So that's the method I'm going to use. I'm going to replace D with 1/2 S plus 20 equals 3/4 times the quantity S plus 20. Well, from here we have lots of options for solving. And the first thing I think about is, really I just want to get rid of this fraction, this 3/4. So I think I'll start by distributing the 3/4 to what's inside my parentheses. So I have 1/2 S plus 20 is equal to 3/4 S plus And then with the 3/4 and the 20, I can put 20 over 1, and I can simplify multiplying these numbers by cross-canceling 4 and 20. I'm simply multiplying two fractions together, so I can use this shortcut. I'm going to divide both 4 and 20 by 4. 4 divided by 4 is 1, and 20 divided by 4 is 5. So 3 times 5 is 15. 3/4 of 20 is 15. That makes sense. Okay, so we need to get all of our variables on the same side. So to do that, I'm going to subtract 1/2 s from both sides. 1/2 s minus 1/2 s is 0. I'm going to bring down 20, and that equals. Now, to subtract fractions, I have to have common denominators. So 1/2 is also 2/4. So I'm going to change 1/2 to 2/4 so that I can subtract these. And then when I subtract, you just subtract the numerators. 3 minus 2 is 1, and your denominators stay the same, 1/4 s, plus 15. Next, I need to subtract 15 from both sides. 20 minus 15 is 5, and 5 is 1/4 of the sister's age. So finally, I need to multiply both sides by the multiplicative inverse of 1/4, which is 4 over 1, or just 4. So multiply both sides by 4. 4 times 5 is 20, and 20 is her sister's age. 1/4 of 4 is 1. So we're left with S, the sister's age. Well, remember that Dorothy is half of her sister's age. So since we now know her sister's age is 20, we know that Dorothy is half of that, and half of 20 is 10. So that means Dorothy is 10 years old. You could have solved this also by just kind of playing with the numbers, playing with the answers, and seeing which ones would work with the information you were given. But I always love to solve a good algebra problem. If A equals -6 and B equals 7, then 4A times the quantity 3B plus 5 plus 2B equals, if we want to find the value of this expression, then the first thing we need to do is substitute -6 and 7 for A and B respectively. So 4, this is actually 4 times A. Anytime you see a number and a letter written next to each other like this, that's multiplication. So I know that when I replace A with a -6, it's going to read 4 times -6. And you can use a little dot for a time sign, or you can even use the X for the time sign. But I'm just going to use parentheses. And then these parentheses here, since there's no sign between the A and the parentheses, not a plus sign, not a minus sign, or a division sign, again, it's understood to be multiplication. So this is times the quantity, 3, again, times B. B is 7, plus 5, plus 2, again, times B, which is 7. Now there are a lot of parentheses here. So what we can do to kind of minimize confusion is we can change these parentheses into brackets. And it still means the same thing. They act exactly like parentheses do. But sometimes it makes it look a little less confusing if you don't have all those parentheses everywhere. So in order to simplify this expression, we have to follow the order of operations, sometimes referred to as PEMDAS. I'm going to write that over here just so we have it to refer to, which is that we first always must simplify inside our parentheses first, Then we would simplify any terms with exponents next, followed by simplifying our multiplication and division operations from left to right in our expression. So just whichever one occurs first in our expression from left to right. And finally, we would simplify our addition and subtraction operations, also from left to right. So following PEMDAS, we first need to simplify these expressions inside our grouping symbols. So I'll bring down my 4 times negative 6. And then inside my grouping symbols, I also have to follow the order of operations. So now looking inside these grouping symbols, I have 2 different operations. I have multiplication, 3 times 7, and addition, plus 5. So if we refer back to PEMDAS, we need to do our multiplication before we do our addition. So I'm going to start by multiplying 3 times 7, which is 21. And I'll bring down plus 5 plus 2 times 7. We haven't finished simplifying inside our parentheses or grouping symbols. So we must continue simplifying inside our grouping symbols until we're done. So that means the next thing I'm going to do is simplify 21 plus 5. So I have 4 times negative 6 times the quantity 26. And I can now just use parentheses again because I'm just multiplying times another number, plus 2 times 7. So we finished with the parentheses, which really, I know it looks like we haven't, but what this parentheses, what that P actually means, is not just parentheses. Any parentheses you do, simplify them. No. Doesn't mean that. It means any parentheses that act as grouping symbols. So parentheses that group more than one term together. And if you'll look at our parentheses, none of the ones we have up here are grouping more than one term together. Each set of parentheses just has a term in it because it's really acting as a multiplication sign, not as a grouping symbol in this case. So the only operations we have left are multiplication, 4 times negative 6 times 26, and addition. And again, according to PEMDAS, we need to do that multiplication before we get to addition. And we work multiplication division simply from left to right. So I'll first multiply 4 times negative 6, which is negative 24. Positive times a negative is a negative, times 26 plus 2 times 7. So we want to continue working our multiplication from left to right until we've simplified all multiplication, which means I need to multiply negative 24 times 26 next. And I'm going to do that just right here to the side. 26 times 24. 4 times 6 is 24. So you write the 4 and carry the 2. 4 times 2 is 8, plus 2 is 10. And then we use a 0 placeholder so we can move on to the 2. 2 times 6 is 12, write the 2, carry the 1. 2 times 2 is 4, plus 1 is 5. 4 plus 0 is 4, 0 plus 2 is 2, 1 plus 5 is 6. 624, and that's after we added. But it was a positive 26 times a negative 24, which means it's a negative 624 plus 2 times 7. We're almost there. We need to continue with our multiplication until we've multiplied all the terms there are to multiply, which means we next need to multiply our 2 times 7. So we have negative 624 plus 2 times 7 is 14. Now we finally simplified it down to our very last operation, and that is addition. And we're adding two numbers with different signs. One's negative, one's positive. When you're adding numbers with different signs, you need to subtract the numbers and take the sign of the number with the larger absolute value. So 624 minus 14 is 610. And since 624 is negative, our answer is negative. So your answer is D, negative 610. Mark is driving to Phoenix from a city located 210 miles north. He drives the first 10 miles in 12 minutes. If he continues at the same rate, how long will it take him to reach his destination? We can use a proportion to solve this problem. We know that the first 10 miles took him 12 minutes. So that's one ratio. 10 miles took 12 minutes. What we want to know is how long it took him to drive the 210 miles. And since it's at the same rate, he continues in the same rate, we can use this proportion to solve and find how long it's going to take him in minutes. Miles to minutes, miles to minutes. And to solve a proportion, we cross multiply. So 10 times x is 10x equals 12 times 210. So I'm going to multiply that right over here. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 0 placeholder. 1 times 0 is 0. 1 times 1 is 1. 1 times 2 is 2. And we add these together. 0, 2, 5, 2. So 2,520. And then to solve for x, we need to divide both sides by 10. So x equals, you can just cancel a 0 here, 252. 252 what? Well, 252 minutes. But as you can see, our answers aren't in minutes. They're in hours and minutes. So we need to figure out just how many hours and then leftover minutes there are in 252 minutes. And since there are 60 minutes in 1 hour, I need to divide 252 by 60. So 252 divided by 60. So 60 does not go into 25. 60 goes into 252. 60, 120, 180, 240. So 4 times, because 4 times 6 is 24, and 4 times 60 is 240. We subtract, and we get 12 that's left over. So that means 252 minutes is 4 hours and 12 minutes left over. So that is answer choice B, 4 hours and 12 minutes.